Welcome to the last breakfast. Please enjoy the video.
You start by enabling hardware acceleration. Go straight to Notebook Settings and select GPU, typically NVIDIA T4, to get CUDA support. Once done, create a new notebook using the Python kernel and confirm RAM size matches your workload. Make sure you attach the dataset from the Datasets tab or upload files to the notebook environment so your code can access them immediately. This first step gets the runtime and data in place, so you can run GPU-accelerated libraries without delay. Next, configure the software stack for GPU work. Check the GPU driver with NVIDIA SMI to confirm CUDA version, because mismatched CUDA and deep learning builds cause runtime errors. Then install required libraries. Use pip install R requirements. TXT or apt for system packages, so versions remain reproducible. After installing, run a quick test. Import Torch and call Torch. CUDA is available, or in TensorFlow list physical GPU devices. If the test passes, now run your training or inference while optimizing for the limited GPU session. Start with small batch sizes, enable mixed precision where supported, and use gradient accumulation to mimic larger batches. Make sure to checkpoint models frequently and save outputs to the notebook's output directory or a new Kaggle dataset because sessions can time out. If the GPU disappears or libraries error, restart the runtime. Re-enable GPU in settings and rerun your installs. Also verify NVIDIA SMI output to quickly pinpoint driver or allocation problems.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.